the graph of y is equal to 10 minus 8x squared for the range of x is minus 1.5 to 1.5 is drawn on the grid. So this is the graph of quadratic function. This is the quadratic function. And student, you know that when x is negative, because here x square is negative minus 8x squared, so it is inverted U graph. The shape of the graph will be look like this. If x square is positive, so it will be this U. But right now it is negative, so look at here, it is inverted U. And the range of x is from minus 1.5 to 1.5. It is from x is from minus 1.5 to 1.5. And the student, this constant in any function, this constant here, it is y-intercept. You can observe here, y-intercept means the graph will cut y-axis at 10. Look at here, this graph is cutting the y-axis at 10, so this is y-intercept. Y-intercept is 10. Write down the equation of line of symmetry. In quadratic function we always have a line of symmetry, and this line of symmetry always passes through the highest point, the turning point. Let me call turning point. Line of symmetry always passes through the turning point. So this is the turning point, and it is the highest point right now. So from here, this vertical line which is over here, which is y-axis right now, this is the line of symmetry. And it is vertical line, so this is cutting x-axis at here 0, so its equation will be x is equal to 0. So this line of symmetry divides the graph into two equal parts. So you will have the same shape on this side and the same shape on this side. You can check the distance from here to here and here to here are equal. And it always passes through turning point. This is the turning point. On the grid opposites, draw a tangent to the curve where x is 0.5, and then find the gradient of that tangent. So x is 0.5. This is x 0.5, and let's go up to the graph, and this is the point on the graph where x is 0.5. We have to draw tangent over here. So let me put the ruler here. Adjust the ruler so that this angle and this angle must be equal. So just little bit more. Just little bit more. I think this little bit more. I think it's good because here the gap over here and gap over here looks equal. So now let me draw a tangent line. Now I have just drawn a tangent line. This is the tangent line. It just touches this point of the curve. To find the gradient of this line, we use the formula m is equal to y2 minus y1 over x2 minus x1. And the coordinate of this point are 0.5, 8. And let me take another point. Let me take this point. The coordinate of this is 1.5, 0. So let me call x1, y1, and x2 and y2. So let me plug these values here. So y2 is 0, y1 is 8 over x2 is 1.5 minus 0.5. Now using the calculator, so the answer is -8. Am I right? Yeah, -8. So gradient is -8. The next part, the table shows some values of this function. So complete the table. Okay, so let me put values here. So -1. So I will put here -1 here in x cube. So 1, use bracket, -1 cube, and then plus 3x plus 3 x we put in x we put -1 and then plus 4. So the answer is 0. So here answer is 0. Next we put minus 0.5 in x. So just bring cursor here. Minus 0.5 and bring cursor here. Minus 0.5. So it is 2.375. It is 2.4. Let's put 0 now. So bring cursor here again. 0. And now 0. The answer is 4. Okay, now we have failed 3 marks. On the grid, draw the graph of this, which is, and the table of this is given here for x from minus 1.5 to plus 1.5. So let's draw this. Let's draw this table on the same grid. Okay, so minus 1.5 and minus 3.9. And there is a 2 to 4, there is a gap of 2 which is divided by the 10 boxes. So 2 divided by 10 is 1.5. So one small box is, there is a gap of from 2 to 4, the gap is 2, and it is divided by 10 small boxes. So divided by 10. So therefore one small box is equal to 0.2. Okay, so the first point is minus 1.5 and 3.9. So minus 1.5 and 3.9. It is 3.9 is, it is 3.8 and it will be 3.9. First point, and then minus 1 and 0, minus 1 and 0, then minus 0.5, minus 0.5, it is over here, and 2.4, 2.2 and 2.4. Am I right? I think I did some mistake. It is minus 1.5 and minus 3.9. Minus 3.9 will be in the here. It is over here. So this is not correct. Let me remove this. Okay, now it's correct now. Okay, the next point is so 0 and 4, 0 and 4. Then 0.5 and 5.6, 0.5 and 5.6. So it is 5, 5.2, 5.4 and 5.6. 1 and 8, 1 and 8. It will be over here. 1.5 and 11.9. 1.5 and 11.9. This is 11, 11.8 and 11.9. Just a little bit more. Now we have to join. It is little bit harder to draw a curve on the computer. Okay, so this is the curve of this table. So this has 4 marks. Show that the values of x where the two curves intersects are the solution to this. Basically, these two graphs intersect over here and here. So here the x value is, it is just over here. So it is because there is a gap of 0.5 and this 0.5 is divided by 10 boxes. 0.5 divided by 10. So one small box is equal to 0.05. If we multiply by 2, so 2 boxes are equal to 0.1. So it is minus 1. So it is minus 1.1. So it is minus 1.2. Yeah, minus 1.2. So okay. So the first solution is minus 1.2. Here the x value is over here. So minus 0.6 and it is 0.65. So 0.65. So these are the solutions of these two functions. One is this, and the second is this, because these are the point of intersection of these two graphs. So these are the solution. These two are the solution of these two functions. So these two are the solution of these two functions, the blue one and the black one. And the function of the black one is 10 minus 8x. And the function of this blue one is x cubed plus 3x plus 4. So I have written these two functions here. One is already written here and the second one is here. So those are the solution. These two are the solution, which is the point of intersections. So these are the solution of these two functions. Okay. Now it is asking us, show that the value of x where the two curves intersect are the solution of this equation. Now I have just told you that the point of intersections where the x value is minus 1.5 and 0.65, these are the solution of these two curves, and those two curves have these functions. So it means if those two values are the solution of these two functions, so we can write them like this. So this is here. Let me write this y. This is the value of y, and I will put this y here, x cubed plus 3x plus 4 equal to 10 minus 8x squared. So student, remember, if the solution where the two graphs intersect each other, those are the solution of these two functions. So when the when two functions have one point of intersection, and that point of intersection is the solution of these two curves, we can write these two like this. And now we can say that these two solutions, which is a point of intersection of these two graphs, these are also the solution of this function, this equation. Now just do a little bit of manipulation, bring them here. So this will, the shape of this equation will change. It will change like this, x cubed. Bring this x square over here, it will be plus 8x square. And then this 3x. And this 4. And bring this 10 over here, it will be minus 10 equal to 0. So it is x cubed plus 8x square plus 3x, and now it is minus 6 equal to 0. So now we can say that the point of intersection is the solution of this black curve and this blue curve, and these two have functions x cubed plus 3x plus 4 and y is equal to 10 minus 8. So these are the solution of these two functions, and we can write them like this. So those are, so it means that these two are also the solution of this equation. And when we manipulate this, after a little bit rearrangement, this equation has converted into this shape. So that's the point of intersection is, which is these two, is the solution of this equation as well. So this is how we have converted these two functions into the single equation, and then after a little bit rearrangement, this has converted into this shape. So the solution of point of intersection, the point of intersection is the solution of these two, which has been converted into this shape. So that solution will also be the solution of this. So after rearrangement, it has converted into this. So that solution will also be the solution of this. And now the last part, by drawing a suitable straight line, solve this. Now we have to draw a straight line on the graph, and now we have to find the solution of this equation, which is cubic equation. If you look at this D part, here what we have done, we have just combined, look at here again, we have just combined this. We have written this, these two in a single equation like this, and then we have, after rearrangement, we have converted into another cubic equation. In the next part, we will do the reverse of this. Look at the last part. In the last part, we have drawn the graph of this one, which is x cubed plus 3x plus 4. So I have written that here. So let me repeat. We have just drawn the graph of this cubic function, okay, which is this blue one. We have just drawn it. To come to this last part, we have to solve this equation, but graphically. So what we will do here, we will compare this with this, because we have already drawn the graph of this. So compare this and this. So here we have x cubed, which is already here, but we don't have, here we have 3x, but we don't have 3x here. So, and we don't have 4 here as well. So bring these two on the other side here. It will become minus 5x, and plus 2 will become minus 2. Now just compare again. So here we have x cubed. Okay, that's good. But we should have 3x plus 4 here as well. So write 3x here and here, both sides. And plus 4 here and here, both sides. So after simplification, it will become this and this same, minus 2x, and this the same, plus 2. Okay, now we have converted this into this shape. If you rearrange it again, if you bring these two over here and after simplification, you get this again. So it means that after rearrangement, this can be converted into this shape. Basically, these two are same. This one and this are the same thing. But after just rearrangement, the shape of this has become this. So it means the solution of this and the solution of this will have the same solution. Basically, they are same equations. Just after rearrangement, we got this. But this will give us some advantage. So the solution of this will be the same. The solution of this. They both will have the same solution. So, but here we can see that we have already drawn the graph of this, which is this one. Exactly same. Now we just need to draw the graph of this only. And this is the straight line. Okay. So we have found that straight line here. Now we just draw this straight line. So to draw this straight line, we need just 2 points. Put 0 here. So 0, it will be 2. Putting 0, we will get 2. Let me put 1 here. So minus 2 into 1. I put 1. So minus 2 into 1 is minus 2. So minus 2 plus 2 is 0. So we got 2 coordinates. Let's draw these 2 coordinates on the same graph paper. So the first coordinate was 0, 2, which is over here. And the second one was 1, 0, which is over here. So let me join these two. 0, 2 and 1, 0. This is 0, 2 and this is 1, 0. So let me use ruler. Okay, this is, I think it's more appropriate now. So let me draw a line. So I have just drawn the line. So this is the line. Okay, so the point of intersection of these two, over here the x, the value of x is, it is over here. So 1.1 and it is 1.15. But we need not to find that solution. So we have just proved that. We have just proved that if we combine, we can rearrange this equation into the shape like this. We can rearrange this by drawing a suitable straight line. So we have just drawn, and we have just drawn the line, and now we have to solve this equation. And we know that the solution of this equation will be the solution of this one, and the solution of this one will be the point of intersection of this graph and this graph. And what is that point of intersection? So the first one was 1.1 and 1.15. 1.15. And these two graphs intersect. No, sorry, I'm wrong. So we have to find the point of intersection of this blue one and red one. Sorry. So here they have intersect only at one point. This is the point of intersection. So the answer is this one. So it is approximately 0.4 and 0.45 minus 0.45. So the solution is minus 0.45. So the solution of these two is basically the point of intersection of these two, and basically these two are formed from this after rearrangement. So this is also the solution of this. I hope you understand.